Welcome back. We're going to talk about friction today. Let me change this pointer here. Okay, so you can see a Top Fuel dragster here. They really go super fast. They accelerate super fast, very quickly. And so friction is super important for dragsters. So friction is created whenever two surfaces try to move past one another. On the microscopic level, what you can see are irregularities in each surface. And these irregularities, these little bumps and grooves, impede motion. They kind of stick on each other and bump past each other and pull. And so smoother surfaces are going to give you less friction because you're going to have less sticking and bumping and grabbing of these tiny little irregularities. But if you have a rougher surface, you've got more of these irregularities and they're really going to grab onto each other and prevent you from moving. So this force is friction. So these Top Fuel dragsters, this is pretty cool when you can see in the slow-mo that you really need a lot of tire to provide a lot of friction. So you can really see that that tire is pushing against the pavement, and you can see spots where it slips a little, but for the most part that tire really stays stuck to the road as it's moving forward, as it's pushing that car forward. So this is like a Newton's third law thing. We've got equal opposite forces, action reaction pairs. Tire pushes on the ground, ground pushes back on the tire, and you need a lot of friction to prevent that tire from slipping. So you saw a section where it was slipping a little bit, and then after that, it really got a good grip and started accelerating forward. So you can watch the science behind these big tires. It's pretty cool. So you check out my slides and watch that video if you're interested. Okay, so our equation for friction. Friction is a force of resistance between two surfaces. The formula for friction, F sub F, equals mu times F sub n, where F sub n is your normal force, and mu, that little, it looks kind of like a backwards U with a longer tail. Mu, M-E-W, mu, is the coefficient of friction. It does not have units, it is unitless, okay? So it's kind of like a ratio. So Greek letter mu is that backwards goofy looking character. So mu depends on both surfaces. You can calculate this if you know your frictional force and your normal force, or you can look it up for various surfaces. So like rubber on linoleum would be your foot on the floor, or an ice skate on ice, or like steel on ice would be an ice skate on ice, or rubber on blacktop would be a car driving. So you can find and look up a lot of these coefficients of friction, or you can calculate them. So we have two main types of friction. There's static friction and kinetic friction. And the AP exam will expect that you can differentiate between these two. So static friction is the frictional force that must be overcome in order to initially move an object. So when I first start pushing on something and it hasn't quite moved yet, it's a little sticky, it sticks at first, that's static friction. So static, we usually use that word for when things aren't really moving yet. Kinetic friction is the frictional force that occurs when an object is in motion. So when I start pushing something, if you notice, maybe push something across your desk or your table. Like I'm trying to push my calculator right now, and there's an initial little stick, and then it just starts moving kind of at a constant rate. So the kinetic friction would be the friction occurring while the object is in motion, while it's moving. Typically, static friction and the coefficient of static friction are greater than the kinetic friction. So static friction is usually bigger than your kinetic friction. It usually takes a little more effort to get something started moving than it does while it's already in motion. Okay, and you can think about things like inertia for this. Inertia is partly to blame. So I've got some examples that I would like you to attempt on your own. I will read through them here and show you the solution page. So a 3.75 kilogram block is pushed along a tabletop with a force of 45 newtons. The coefficient of friction is 65.65. Sorry. Find the force of friction, then find the acceleration. So for this problem, you've got the mass of the block, you have a force of 45 newtons, an applied force, and you have a coefficient of friction. So draw a free body diagram, and then you can solve this problem. We have another example. A 0.2 kilogram puck is pushed along a sheet of ice with a force of 0.24 newtons. If it moves at a constant velocity, find the coefficient of friction. So remember, the constant velocity means balanced forces. Okay, so that would mean your frictional force is equal to your applied force, that push. Okay, so that should help you solve that problem. And then finally, this one, I guarantee you there's going to be something like this on the AP exam, and I might test you on it later in the week. We'll see. We've got a 1.1 kilogram textbook. It's being held against a wall with a force of 45 newtons. So somebody's pushing this book against the wall. What is the coefficient of friction between the book and the wall? This one can be tricky, but it's really easy once you figure it out, once you figure out what direction the force is going. So carefully draw a free body diagram of the situation, and remember that the normal force is perpendicular to the surface. Doesn't mean it's going up all the time. It just means that the normal force is perpendicular to your surface, in this case, the wall. And friction opposes the motion of the object. So that should tell you what directions your normal force and friction force should be in. Your applied force, you're pushing the book into the wall, and you've got a gravitational force. So think about that before you solve these problems. I do have my solutions drawn here for you, so you can pause the video and take a look at those if you're trying to solve these, or you can go on to our Google Classroom and pull up the solutions for yourself. So for example 1, you should get 5.63 meters per second squared. Example 2, your coefficient of friction should be 0.12. And for example 3, your coefficient of friction should be 0.24. Okay, that was friction. I've got some homework posted for you in Google Classroom, and we'll see you next time.